Hello everyone. So, today we are moving on to our Python lesson number 7. Now, this lesson will be about collections. So, this lesson will kind of go into detail of basically every collection that Python has and kind of all of its uses, why we would want to use them, and why each one of them is unique. Now, Python collections are quite unique compared to other languages, as the way they store them, as well as the possible information that can be stored inside the Python collections, is quite different than those in different languages such as Java, which I will go over later. But without further ado, I guess let's get started. So, a kind of brief overview of what a collection even is. So, variables are used to store a value or store data, and that data is then used for the CPU to process. And say we needed to store the number of apples picked by 10 friends. Now, 10 friends is 10 variables, and that can get very confusing as a programmer, as that's 10 separate variables that you need to keep track of. And as you can see over here, we have these 5 names over here, and these 5 names can be kind of hard to remember to track as a programmer. Now, what a collection does is, instead of having you to define 10 different variables, it instead allows you to store it as one collection holding 10 different values. Now, if we go to the definition of collection, like as an English word, then a collection is essentially just a bunch of objects, a bunch of things, kind of like stockpiled in a certain place. So that's what kind of a collection of, say, a collection of toys. You could have a lot of toys stored away. And so essentially Python collections is just going to be that same thing, kind of a lot of different values or a lot of data stored inside one object. So the reason why we want to use these collections is it allows us to keep track of the variables better, keep track of our data better, and organize it in a way where it is easily understandable. So we're actually going to go back to this site later on, and this will kind of tell us slightly more about lists. But essentially, what is so good about these Python collections is that they allow you to simplify a lot of your programming, and it's very easy to kind of track your train of thought when you use collections rather than multiple variables at a time. So here's kind of an example. You have this collection, and it has all of these variables in it. So now, if, say, you wanted to access some of these, then all you would need to do is you could say print tnj, and it would give you all of these, and you would know, oh, I have all of these variables. Okay, now that I have all these variables, I know I can do XYZ with them. And having these collections is always useful in tracking your information, as when you get more advanced in programming, then all your values, there's going to be more and more data that you need to store, more and more data that you're going to be manipulating inside of your programs. And the best way to keep track of all of this data is using collections. Now, not only is it easier for you, but sometimes it can be easier for the computer as well, as storing the information in collections can allow the computer to access the data in a faster manner, especially since typically if you're programming with collections, there are certain set commands that you can run, and it will run whatever you want in the most efficient way possible. Now, you could program this yourself, of course, but it saves a lot of hassle, and it allows your computer to kind of run on a lower runtime. So, this is kind of our introduction, or the very beginning of collections. This is known as a list. Alright, so the list is the very, very basic Python collection. As a matter of fact, it is the basic collection in practically all programming languages. Now, some of them may be called a little differently. Say in Java, it's called an array, but in Python, it's called a list. But essentially, what a list is it is a very it's an ordered kind of a ordered by insertion, a list that stores all your values. There's nothing really too special about it. However, there is a difference between a list and array, and I'll kind of explain that later on. But essentially, these are kind of the basic characteristics of a list. So, first off, it is ordered. So essentially, elements will stay in the exact same order that you inserted them in. So it will not auto sort them to alphabetical order for you. It won't insert it in random positions in the list. It will always append it at the end, and it will remove wherever you tell it to remove. Now, another thing is that lists are mutable, or essentially these lists can be updated or changed, and this is important as there is a collection in Python that doesn't allow you to change it, and many times so this kind of gets a little more into depth with how the computer kind of stores your data, but essentially you always want the most efficient collection possible. So if it is possible, you will always want an immutable list rather than a mutable collection. And so, but being mutable is one of the unique things about a list, as it can be changed. Next, it allows duplicate members. So this means that if you were, say, storing the numbers that you passed in a certain pattern, and you wanted to know if you could find the pattern, essentially it would just keep on printing it no matter what the value is. So like in this list below, you can see two 3.5s. So it's not very good at detecting, oh, there's two values going on here. Two data values that hold the same value. And this can be helpful in certain situations, but this is one of the unique things about a list. And finally is going to be the most unique thing about Python lists. It is heterogeneous, or elements do not have to be of the same type. As you can see, you have a string, you have an integer, you have a double or a float, and these three are all different data types. Now, what does this make this list? So this list over here is going to be it's going to be of its own type. So in many other languages, each list has to be defined by a certain type. And the reason for this is because inside each one of the values, there is going to be a certain kind of memory location assigned to it. And by telling the program that this is going to be, say, an integer, then it will be able to kind of assign all of these different slots just to this certain list. And so as a result of this, it is very easy it is very efficient in the program in terms of storage. Now, although this Python list might not be the most efficient in terms of storage, as you can see, you have an integer and you have a string, and these two are vastly different in their storage sizes, so Python has to be able to account for that and be able to kind of change it on the spot whenever it's needed. And this can result in a loss of time, or essentially the program will take longer to calculate each size, and that's kind of one of the downsides of being a heterogeneous list rather than a homogeneous list. So these are kind of like the basic characteristics of a Python list. We're going to go over through some of the examples in more detail later on, but these are kind of the that's kind of the basic information. So you guys can read over that for a second. So you guys have had some good time to look at it. We can move on. So a list is essentially a new kind of data type, except it's quite unique data type, so we're not going to exactly call it that. So it's going to be our basic collection. So obviously, if we have a list, we're going to want to be able to manipulate every single value in the list as easily as if they were individual variables. So the way we would do this is the index of the list. So the index is essentially a number assigned to a list, or the order of the list. And at each index is going to be a certain value that you assign to it. And this can vary from obviously all of these data types. And the index will always start at 0 and will always go to the length of list minus 1. So essentially, we can see that this list has 6 different items in it. And since this list has 6 items in it, then that means that the index of the list goes from 0 to 5. So as we can see, 0, 1, 2, 3, 4, and 5. And this can be helpful in that we can now understand how we can access each one of the values in the list. So if we think about it, now that we know, oh, this is how we can kind of keep track of where these elements are stored, then that means that we can also kind of keep track of, oh, now I know that I can modify each one of these boxes. Now, this can be kind of another downside of lists, in that, say you have a list and at index 0 it is equal to 2, an integer. Now, it's perfectly fine for you to say go ahead and change it to a string. However, this means that Python or your computer now needs to allocate more memory to that certain spot. And this can often be a hassle, as the computer has to kind of like shift around memory spots. And again, this is why a heterogeneous list is highly not recommended in programming. And it is why Java standardizes only a single data type in its list. Now, another reason for this is getting a little bit technical, but essentially the implementation of a list in Java is slightly different than that in Python. And what I mean by that is, how exactly is the list created? Now in in Java, the list is created by using consecutive memory spaces. So these consecutive memory spaces, so think of it like we have memory spaces from 0 to 2000, and in each one of these memory spaces we can store 1 bit. So essentially we have 2000 bits. Now an integer is going to be, say, 8 bits, and in these 8 bits we can store a single integer. So essentially what the list will do is it will assign 0 to 8 is integer 1, or integer at index 0, and it'll keep on going. And this is why a list in a list in Java, or an array, is immutable or unchangeable, because after these memory spaces get used up, and say you store another variable after this, then all those memory spaces can no longer kind of be edited anymore, because it's kind of locked in between the variable that you stored before it and after it. So that's kind of why in Java arrays are immutable. Now in Python, it's more flexible because that is not the implementation of lists. And the reason for this is because it's kind of ease of access for the programmers. Now, it's always easier for a list to be more flexible, more easily changeable, uh, mutable, essentially. And the advantage of that is obviously going to be that there's not many restrictions. You're very free in doing it. But the downfall of this is that you lose a lot of time. And by losing a lot of this time, then in more complicated programs, it can lead to a program taking, say, twice as long than it should. Or in programming terms, the big O of the entire program would increase. And you never want the time of a program to increase because many times you're performing a lot of calculations at once. So I know that kind of speech was a little technical, so you don't really need to completely learn it, but it's kind of interesting to see how Python works as compared to a language like Java. So as we can see, we have all these indexes down here, and they are all set at their own values. And these values are obviously going to be different data types, and this is kind of how we can edit it. And this is only editing directly. Next, we're going to move on to adding elements. Now, this is going to be these methods, I guess, or these different commands that you can run or write, are going to be append, insert, and extend. So we can have this base list over here of 4 different values, and this initial set or list of elements is going to be initialized. So what initialize means is that you have just defined this list and you have given this list a value. Now, there are Python built-in functions. And what built-in functions means is essentially when you download Python, right? So there's obviously going to be the IDE, the Python itself, being able to run it, convert it to machine code, right? But there's also these things called libraries. And these libraries are interesting in that it's essentially pre-written code. So what does pre-written code mean? Well, it means that essentially, instead of having to write the code for yourself, Python has gone and written the code for you, so there are many basic actions that programmers will need to call over and over again, and Python feels that it is so basic and that it needs to be a kind of a tool that all programmers can use rather than having to write it every single new program that they write. And these 3 different commands are the append, insert, and extend. And you can read over what they do over here. So essentially, append is going to be, like the English definition, adding an element at the end. Insert is going to be adding elements in the middle of the list. So as we can see, append only has one parameter, or new element, because append is essentially inserting except at the very end, right? So all that needs to be added is just the element. Now with insert, you're going to need 2 parameters: the index at which you want to insert it, and the element that you want to insert. So inserting is kind of, it's not replacing an element, but it is essentially adding an element at the index and pushing everything else back one. Now extend is going to be kind of like append, except adding more than one element at a time. So I know this is kind of a lot to soak in, so I'll let you kind of read over this slide and think about what I said. Yeah, so I'll leave you guys to that for a little. now we can move on. So, now that we know that we can add elements, there's obviously going to be the opposite. Because what use is adding when you can't remove them? Now, these three functions are also going to be built-in functions. And these built-in functions are remove, pop, and pop at an index. So, essentially, what these are is essentially remove is going to be removing a certain element from the list. So essentially, say you want to remove, in this list back here, hello. It will be able to remove hello for you, and the list will read 2, 3.5, and world. Next is going to be pop. So pop is essentially removing the last element from the list. And popping at an index means removing the element at a specific index of the list. Now, we have to make sure that we understand that remove is not removing at an index, but removing a certain element. So, say you don't know the specific index of the element that you're trying to remove, then you can use the remove function. However, if you know the index, then you should always use pop, as it is more time efficient. And time is, as I've repeated before, it's a very, very important thing in programming. One of the two major things. So, finally we can move on to multi-dimensional lists. So, this is going to be kind of different than a list, in that instead of storing regular data values, it is going to store a list within itself. So, a list of lists. And as we can see, there's kind of 3 different lists inside this one big mult list. And there's nothing really unique about this list other than the fact that, well, instead of storing regular data values, it will store lists. So, obviously, every single command is going to be the same. So, say you wanted to access world in the first list. So, what you would do is you would be able to access at index 0 of mult list, you want to access index 1, and that would return you world. So that is kind of how you're able to move around a list inside a list, or a multi-dimensional list. And the dimensions of a list, or I guess the lists inside of lists, can go on infinitely. I really would not suggest you to do that, as it's not entirely the most efficient way, but obviously there are certain special situations in which a list inside a list can be helpful. So, now we're going to move on to tuples. So, throughout these next kind of data collections, I'm not going to be spending as much time as I am going to be on lists, and the reason for that is because lists is going to be the basic Python data collection. It is going to be the Python collection that you're going to use the most by far, and it is one that you should really familiarize yourself with, because it is very, very useful in many, many situations. And in fact, the basic Python collection of a list can be used to write more complicated Python collections specialized for certain situations. And perhaps we'll be able to talk about that later on, but it is a little bit of an advanced topic. But anyways, we're going to move on to tuples. So, tuples in Python is essentially a list, except it is immutable. And just like an array in Java, a tuple means that it cannot be changed once created. And you can see over here, when you define a tuple, instead of using the brackets as you see in a list, you're going to use parentheses. And that will kind of show you, oh, this is a tuple, not a list. Now, it can be a very confusing mistake if you're trying to create a list and you use parentheses and you're like, hey, why can't I change the value? Well, the reason is because you just created a tuple, and a tuple is immutable. So, immutable means that not only can you not add values, but you cannot remove values. And the values within the list, or the tuple, cannot be changed. So essentially, hello cannot be changed to by. So sometimes there are certain values that we want to be stored, and they should not be changed. So uh, the reason why you would want to use a tuple is not necessarily because I don't want to accidentally change a value, although that can be a valid concern, but also that you don't want to take up too much storage. And that is kind of the use of a tuple, and essentially these values are known as final values or permanent values. And these permanent values are essentially kind of base values, or values that are kind of given to you and you are not meant to change throughout the entire program. You will obviously encounter these later on in your programming, and a tuple will be very helpful in storing multiple of them. Our next data collection is going to be sets. So sets in Python are also similar to lists, but they cannot contain any duplicates. In addition, sets are unordered, so you cannot access an individual element in the set using the index. So as you can see, we define the sets using a bracket or set parentheses bracket. I should probably call that squiggly bracket, because bracket and squiggly bracket are very different from one another. So the use of a set is going to be used for storing individual values. Say I want to see which values are possible when I like spin a wheel or something like that. And it's very good in tracking the possible data values or the possible outcomes of a certain thing. And the set can also be very useful in many other situations. I'm not going to go into too many specifics because there are quite a lot. Set is a very useful data collection, and other than the difference that it can't contain duplicates and it is unordered, there aren't any other differences than a list. So I'll let you kind of look at this for a second, familiarize yourself with it. Alright, now that we've kind of familiarized ourselves with sets, we're going to move on to dictionaries. So dictionaries in Python are kind of like in English, where a dictionary essentially is just a word and its definition. In this case, there's going to be something known as a key value pair. So this key value pair, instead of going ahead and retrieving each value using indexes, it will use a key. So over here, we can see that the key is going to be Tom and the value is going to be 83. So if we were to call a dict Jerry, then it will return 90 because that is the value. So the dictionary allows us to provide more context rather than just an index to a value. Why do this? Well, many times it is absolutely necessary for you to use that context in order to make sure you access the right value inside a data collection. And a dictionary is obviously going to be the best way that you can do this. You can technically use two different lists, one to kind of store the key in a certain index and one to store the value a value in an index, but that is going to be rather inefficient. So the dictionary was created. And so the dictionary is great in making sure that you have the right context when you store something like a variable or a value. There's nothing much to it, but I'll let you kind of look at how you define a dictionary. The code can look a little complicated. Right. So that kind of wraps up our basic lesson on Python collections. Now we're just gonna go over kind of the list over here really quickly. Alright, so here's a table of contents. This is kind of useful. It kind of tells us the basics. So creating the list, knowing the size of a list, adding elements, accessing, removing, slicing, and all the methods. So creating a list, so you can make a blank list. You can make a list with a certain number of numbers. You can make a list with strings. And here's a multi-dimensional list. So this is going to be the print of what happens over here. This is creating a list with duplicate values. So as we know, a list can have duplicate values, and the data collection that does not have any duplicate values is called a set. So knowing the size of a list, so you can use this command or function known as len, and len will tell you the length of the list. So as we can see, the length of this list is 0, the length of this list is 3. This is going to be the basic application of the append function. The append function will add values at the very end of the list. Next is going to be the insert function, and this insert function will essentially just insert the value at the given index, as we can see right over here. Finally, it's going to be the extend function, and the extend function is going to add values or multiple values at the end of the list. So as we can see, we have 8 geeks and always, and all 3 of those values are added to the end of the list. Accessing the elements includes using the index of the list, and in a multi-dimensional list, using the index of the index within the list of the list. That can get a little confusing. And there's going to be negative indexing, or kind of going backwards from, essentially instead of going forwards, it just goes backwards. I highly suggest you don't use negative indexing that much, as it's not entirely useful and it can be a little confusing if you write your code using that. Next is going to be the remove function, or removing elements. So this is going to be the basic one of removing the element from the list, and if the element does not exist, then an error will be there. So as we can see, it removes 5 and 6 over here, and it removes 1 to 5 using a for loop. So here is the examples. Next is going to be pop, and pop is essentially just going to remove the last element. So as we can see, pop will remove 5 over here. And next is popping at an index, and popping at an index at index 2 will remove 3, 0, 1, 2. And slicing a list, essentially slicing a list, this is the code for it, and it will split the list into, it will kind of slice the elements into a range from 3 to 8, or from here to here. And here's the example of it. So here's the initial list. You can see these items from 3 to 8, 0, 1, 2, 3, and from here 3, 4, 5, 6, 7, 8. So that's how slicing works. Slicing can be useful if you don't have a use for a certain part of the list anymore. Other than that, there's not much use for slicing. And there's also negative index slicing as well. And here is kind of a good summary of all of the list methods. And here are some other ones down here. So I'll paste this into the chat so you guys can click on it yourselves if you guys want to. But other than that, that is going to wrap up our class on collections. If you have any questions, I guess make sure to ask them. And for this week, this is going to be the coding best practice that you're going to want to do. Alrighty, it does not look like there are any questions, so I guess we can end it here. So thank you everyone for watching, and see you guys on Friday.